Hey everyone, Sam here. Let's do another daily Leetcode question. I'll be acting as a tech interview candidate, and it looks like we're doing number 2864, maximum odd binary number. I'll start the timer over here, and we'll kind of approach this as a candidate. I'll be talking about the different approaches I might do to solve this problem, as well as what I want to communicate to the interviewer. So let's see what we have. We are given a binary string S that contains at least one 1. So we're doing binary numbers. How fun. And it's a string. You have to rearrange the bits such that the resulting binary number is the maximum odd binary number that can be created from this combination. So I'm already thinking an odd binary number ends in a 1. Like we know that. That's how you define even and odd, and it's kind of easy with binary, so that's great. We're returning a string representing the max number that can be created from the given combination. Note that the resulting string can have leading zeros. Okay, so what does that mean? We're given, here's an example. The string input is 0, 1, 0, and the biggest number you can make is a 0, 0, 1, because you have to have a 1 at the end. So it doesn't really matter about the rest of it. You can't move the 1s any further to the left. Let's see, 0, 1, 0, 1. So 1 all the way to the left and 1 all the way to the right is the biggest number you can get. The other thing I'm kind of noticing is the biggest binary number you can make is all the 1s to the left. So the question I had in my mind was, could you just keep moving the 1 as far over to the left as you want? You can't, because you only have so many zeros. So you have to have 2 zeros in between, because that's how many you were given. Which in this case, this is the same way as saying that whatever length string you're given is the maximum length, is the length of the string output that you're going to be giving as well. Which is kind of nice. I'm thinking of some approaches already, so let's actually just have a look at the constraints. Some of the questions I might ask the interviewer is, what happens if you're given all zeros? You're guaranteed to have at least one 1, and it's only going to be valid values, 0s and 1s. The length of the string will fit in memory. In fact, it'll not be longer than 100, and it'll be at least length 1. So because we know there's always at least one 1, we know we can always create an odd number, and it'll always be the very rightmost digit. I am thinking, so since we're doing this in Python, one of the things we had to keep in mind is strings are immutable. So there's no real like string manipulation tricks we could do here like we could do in C++, where you literally change the characters by swapping them around. Here we can just go ahead and create a whole new string. No matter what we do, we're going to have O of n, where n is the length of the string, space complexity. And in fact, I think we can also do O of n time complexity, because we just need to count how many 1 digits there are in the string. I feel pretty good about that. So let's think about any other approaches we might do. I mean, technically sorting the string is an argument. I don't think we're going to do that. The approach one we're going to do is count 1s, build a new string, is essentially the logic. And the way we build that new string is, let's say the count is equal to the number of 1s, 1 digits. We're going to take count minus 1 1s all the way on the left, and the last one on the right. And that's kind of that's how we make our string, and we return it. And we're guaranteed to use up all the 1s and 0s, and we're good to go. And this will be all clean and O of n, space and time, which is as good as we can get. Another approach we might have thought about, which may make sense for another solution, is some sort of sorting based approach, where we bubble sort or insert sort the 1s all the way to the left. And this is actually kind of how insert sort works. So this is an implementation of insert sort, and if you haven't heard of insert sort before, you just search through the array looking for a value that's larger or smaller than the current one you're looking at, and if it is, you kind of bring it over and swap it and push it in. And that might be actually kind of bubble sort, but let's not get into the weeds there yet. Any other approaches? Some sort of hash table? No. No trees, nothing special to do here. I think we are just going to go ahead and start with this one. So let's get to implementing. We're about 4 minutes and 11 seconds in. I think we should be able to pull this off. So let's count the number of 1s. So we'll just call that, I think there's something like string.count of 1, something along those lines. I don't actually remember what it's called, but what we can do is just say if char equals 1, and we'll do the sum of this. I think we can do it for C and S. So this creates a generator for every single character inside of the string, and if it's true, then it adds as 1, and you sum it all together, it gets your 1 count right there. When we make a new string, what we're going to do is take the count minus 1, 1 times count minus 1 on the left, plus the length of the string. So let's just create n is equal to the length of the string. I'm just trying to build this all in one fell swoop if we can help it. So we have ones. Let's say our input string was this 0, 1, 0, 1 like this. So n equals 4. We want to create 2 ones, or actually 1, 1, because it's count minus 1 on the left. Then we're going to take the length of the strings minus the ones plus the 1 on the right, and that gives us our final answer. That's kind of the goal here. So this will be n minus count of the characters left plus the final count on the right. And we don't need to do any sort of special check for if the count is 1 or less, because we know there's at least one given in our constraints. So in the case that there's only 1, 1, the count will be 1. 1 minus 1 is 0, so this will be nothing. N minus count will be, let's say 4, and there's only 1, 1, that'll be 3. So 3, oh, and this needs to be times the 0. And this is there, like that. And then our final one at the end, and we've created our string this way. This is a O of n times space kind of approach. I think we could actually do something a little cleaner here later, but let's just keep it like this for now. And in fact, I think we can just return it as is. So I think that's about it. Let me put this up here. There's probably ways to make this cleaner, but I don't. Let's put this in here because we only use it the once. Yeah. All right, what do you think? So this operation is O of n. This operation is O of n as well. That's O of n and O of 1. And this operation is O of n time and space. And so we get our final solution of O of n time and space, kind of like we talked about earlier. Trying to think of any other edge cases here. Am I doing an off by 1? I don't think so. All right, let's test it. Let's have a look. See if I'm missing anything. All right, it passed the test cases. That's great to see. Really happy about that. I would expect it to work for a single 1 digit. Let's just quickly think about that. That's kind of one of the edge cases. That's legal. So the count will be 1. The length will also be 1. This will become 0. Nothing there. This will become 0 as well, so nothing there, plus the 1 at the end. Okay, I think we're fine. Let's try it. Submitting, and we were accepted. Good to see. Happy about that. Nice quick little solution. We're in the bell curve. Plus or minus 10 milliseconds. This is kind of within the bounds of the back end. We can try to think about optimizing, but I feel pretty good about that. That's a nice, clean, straightforward solution. Nothing too crazy. Let's clean this up and push it back here. Yeah. All right, what could we do to make this? And the reason we're doing it this way is because strings are immutable. If there was a C++ approach or C or some other language where you can manipulate strings in place, we might be able to. If we had in place, we could do O of n. I think we still could do O of n time O of 1 space because we're using in place. But I don't think we have access to that here because any sort of in place thing would be generating a whole new list. Okay, could we make this cleaner? I don't know. I'm not sure. Let's have a look at the solutions. I see a little bump right here. They do the same thing. Yeah, they use the s.count. That was the only other trick I was thinking of. We did talk about that earlier. I'd shown this line could be replaced with something like count equals s.count of 1, something like that. I think that should work, and that'll be faster because this runs something like C in the back end. It's good to point out to the interviewer that it exists, and they might let you use it. C is actually still about the same speed. It's not that far off, but it's also good to be able to show that you don't have to use it's also good to be able to know how to do it the other way in case the interviewer asks you not to use that function call. In this case, as an interviewer, I'd be totally fine with them doing it. I would just ask them to explain what it does and how it does it. And if I'm actually worried and this is a phone screen, I'd say, okay, actually, could you do it with a for loop of some sort? Okay, cool. I've been working on a video that involves detecting chessboards and images using computer vision and machine learning. So stay tuned for that. It should be interesting. Anyway, have a good time and see you all next time. Cheers.